Alrighty. Ooh, oh boy. I have maybe enough space for like a single episode. Holy crap. Cool. So, VR Shoota. We need to be able to grab the gun by the handle. So, let's see if we can come up with something. I'm gonna enable Steam VR so that it just sits here. Okay, so here's what I'm thinking. Oh boy. We have our pistol. In order for us to know if we're about to grab it by the handle, we're going to place an area node and then give it a shape. Not this one. This shape. Now, this is going to be grip detect area. Okay, we'll just leave a note in the editor to be detected by the player's hand. All right, we're going to leave it here. And then in the canine pistol, which inherits from the weapon template, we can now populate it with a collision shape, which is going to be a little circle. There we go. Oh. Rodok, good day. Okay, there we go. That's it. That's all that we're going to do. Just place it right here. Okay, so on the pistol, this is the only thing that we're going to be colliding with. Okay. What are we going to do? We're going to place it into a group called grip zone group. Okay. Grip zone group. Or maybe we should call it something more like handle grip group. Well. Well now. This is actually quite an important distinction. I guess gun handle group. Okay, so what if we do something like this? If there's a gun and we're colliding with a handle, that takes priority when we try to grab something. So if we don't collide with a handle, the gun itself is going to be grabbed like it is grabbed right now. Now, we're going to go to the hand. We'll see how this works. Okay, we're going to go to the hand, and we have our grab area signal. Okay, right here. But this is for body entered and body exited. We need to do area entered and area exited for this. Okay, now, if area is in group gun handle group, then, well, we need to kind of do the same thing we did with the grabbables and determine which one is the closest one. Right. Right. Now, for that, we're about to delve into the same exact routine as we did for figuring out what is the closest grabbable. Is that really necessary? Is there a way we can simplify this? Like, for example, can we make the gun know if we're about to grab it by the handle? What else can we do? Is there a solution that we can employ that can be done with what we already have, which is body entered, body exited? we know that we could do a distance check between our palm and let's say the handle, and if it's close enough, right, we would consider that we're about to grab the handle. Huh. What else can we do? We could treat the handle and the gun as two independent grabbable objects. Huh. Which is kind of what we're doing with the area here. Hmm. I think the distance might actually be better because distance is linear while this collision shape is very quite much voluminous. There's volume to it, and it's probably going to be detected quite a lot more inconsistently. Okay, so if we're doing that, if it is a weapon, why don't we do this? Let's go here. Instead of grip detect area, we're going to change type to a node 3D. Okay, grip detect point, and we're going to keep it here. Beautiful. Save it, go here, grip detect point. So we're going to check if our palm, the palm of our hand, is close enough to this point. Okay. Now, what kind of distances are we going to work with? Well, if I place this somewhere around here, let's say that's the distance we're working with. That would be 0.05 by the looks of it. So 0.05 is the distance we're working with. Okay, 0.05. Okay, let's go to the hand. Here we are grabbing something. Okay, if this is a weapon and the hand is close enough to the grip handle, then grab this by the handle. Okay, cool. So the handle will take priority, I think. How do we do this? Well, first we need to verify that this is actually a weapon. So we know that it's in the group, weapon group. Copy that. Now it's going to come in useful. So if closest grabbable is in group called weapon group, then we know that we're dealing with a weapon. So check, I guess we already know what this is. So if closest grabbable dot get node, we're going to get the node called grip detect point dot global position dot distance to distance to what? Well, we need to know the distance to the palm. So I guess grab area will actually work out just fine here. So grab area, global position. So if this distance is less than 0.05, less, there we go, maybe less or equals 0.05, then we know that we have to grab it in a special way. Okay. Okay, let's see. How do we grab it? We grab it I think we grab it the same way we grabbed it in Sublunaris, which is by the use of the grab remote. We could have a custom remote node. That could work. Okay, here's what we're going to do. I believe we can place the grab remote here. Somewhere, maybe even in here. I think that's acceptable. Grab remote. We do need to update any place where we talk to grab remote. Okay, that's good. So we're going to tell the grab remote. First of all, we're going to tell it to assume the path. Tell it where the path of the grabbable is. So same way as we did here. But before we do that, we actually need to position the grabbable object. Okay, so interesting enough, this has to happen, this has to happen, this has to happen. The only thing that should not happen is this, which is the repositioning of, well, technically it does need to happen, but with some additional offsets. Okay. Let's think about this for a sec. Not only, okay, when we grab a regular object, the remote path has to be updated, and the remote transform node has to be positioned where the item is, and that's it, so that the item doesn't like jump around. But if it's a weapon, we need to make the item teleport to the grab remote. Not only that, it has to teleport to the item, and the grab remote has to be positioned in a special way. Okay, but what way is it? Well, we can place the pistol in the scene temporarily. Okay, it looks like it's looking down the Z-axis. I don't know if that is a good thing, but I think that's fine. So we're going to select this. Okay, we might have to deal with this. I'm going to have to tell Dimitar that in Godot, things have to face the negative Z-axis. That's the forward axis. That's fine. Part of the process. So I need to do this. So I'm rotating the remote node. I'm going to place it like this. And now, well, there needs to be some kind of a, I think there needs to be some kind of a pose. So let's open up the project. Make a quick pose for the gun. That should be good. What is it? K17 pistol. Robot hand. Okay, let's hide the armature for a sec. Import. I think we'll do OBJ. I think so. Yes. VR shooter, engine 3, models, weapons, and then body. Okay. Yeah, so this is facing down the wrong axis. That's fine though. Okay, so the hand is pointing downwards. That might be a problem. Maybe. I'm gonna have to rotate it by 90 degrees temporarily. Whew, okay. When we imported the OBJ, it imported as separate objects. Let's try that again. Wavefront, body, do not split object. There we go. Okay. We're gonna have to make sure we remember to bring the alignment back. Okay. So this is what we're going to be seeing. And then we're going to make a new animation. Let's just duplicate this one. So grip K17. Okay, protect it. We're going to place keyframes for all the bones. I might want to make the armature display as wire. There we go, it's easier to look at. Okay. I might want to work in local axis. There we go. Dang it, we didn't record. Okay, one more time. Pose mode. Hit record this time. Individual origins. Mm-hmm. Okay. It might be a bit small, but I guess we'll see. Mm-hmm. Okay. So that should be good. There we go. Record the pose. Nice. And then if we switch the reset, we need to protect this as well. Okay. While I'm here, let's also record another pose. Let me take this to a separate collection. The collection, weapons. Okay. Cool. So we're gonna do another pose, which is a grab pose. There we go. So it's a nice generic grab pose. And I think that should be pretty much all there is to it. Now, I'm kind of tempted to just leave it as it is and just export it this way, you know? Let's see what's going to happen if we do that. Okay. There we go. Alrighty. Oh boy. Okay. I think that's fine. We're just gonna take the robot hand and rotate it by 90 degrees, and that's it. Now we're good. So, I can take the animation player node, tell it to play the grip, and now we can see where the misalignment takes place. So I can do this. I can take the position like this, find the place where it is supposed to be, just like that, and that should be it. Now, this is important. We actually need to record the location and the rotation of the current remote transform node, so that once we grab this weapon, we can use that remote transform, use this location rotation. So to do that, we're actually going to go to the weapon template, and we're going to make some variables. So var grip location, var grip rotation. It's going to be of type vector3 on both cases, and it is an export variable in both cases. There we go. Cool. So now we need to open this pistol. We can see the properties here. We go to the VR hand and copy position, paste it in here, copy rotation, paste it in here. Okay. Now, get rid of the weapon. And then we're going to go to the hand, and when the hand detects that it's a weapon, and we're close enough to the grip, get the path. That's fine, but the remote transform, which might as well happen first. Remote transform, and then we populate the path. We'll just reuse this line of code for that. Remote global position is what we want to work with. Global position, we're going to talk to the closest grabbable, and because we know that it's a weapon in the weapon group, we know that it must have that property called grip location. Okay, and then we'll also do rotation, and I'm pretty sure this rotation is in, it looks like it's in radians. Okay, now this has to happen only if this is a weapon and we're near the grip detect point. Otherwise, we have to treat it like a regular weapon, a regular item, and then pick it up this way. So we somehow need to run either this or this. The problem is that we have two if statements here, so we might actually have to combine this together. So if the closest grabble is in the weapon group, and the distance to the handle is this, we will run this, else we will run this. And the rest has to take place the same way. Now, we're going to have another export, var grip pose. We're going to take the grip pose, which we should have written down. This one. Oh, I might want to protect the grip. Would have been destroyed. There we go. That's the name of the grip pose. We go to the hand. If it's a weapon, we tell the animation player to play the grip pose animation mentioned here. I think this should work. Oh, or we're gonna crash. Okay. Unexpected indentation after if. Well, oh, right. Okay, we're gonna get rid of these area signals for the time being. We're gonna assume that we can get away without them. Disconnect, disconnect. Okay. I need a water. Yep. I'm gonna grab a water. Ooh. Okay. Ooh. Okay. That should be good. Turn on controllers. Mm-hmm. Okay. So that clearly is not detecting it as a weapon. Let's do this. Let's give ourselves some sort of an indication in the hand that we are about to interact with a weapon. So here's what I'm going to do. We are going to copy this whole thing. Actually, indicator goes first. Let's go here, hand rigid body. Let's give it a light. What is it? Let's do an omni light. And just for the time being, I'm going to use a small light as an indicator. This is actually an idea that I got when trying to figure out how to more effectively communicate that the player is about to grab a handle or if he's about to grab something as just a regular item. We're going to put a couple of lights here and they will indicate how the player is about to grab something. Okay, so this is going to be weapon grab. Okay, we're going to make it red. Weapon grab, and let's make another one. This one's going to be green. And this is generic grab indicator. Weapon grab indicator. We could technically get away with just doing one light and then changing its color, but for now we'll just work with this. Okay, now we need these two conditions. We don't need all the code in between, but we'll get rid of it afterwards. Grab process, indicating if player is about to grab a weapon. Okay, so we already have this condition right here. Just gonna get rid of this. Checking if we are close to an interactable. And then inside, we're going to do this. Talk to this node. Talk to this node. Set it both to be invisible. Okay. Now, if the closest interactable is not null, get rid of all this nonsense. Then, if we're about to grab a weapon, we're going to make weapon interactable become true. Otherwise, if that's not the case, we're going to make the generic interactable indicator become true. Okay. So it's all about communication. Okay, there we go. Now, as you can see, oh, so it's there. The distance might be too small. Okay, we crashed, but it did detect it. Invalidate index grip location on base rigid body 3D. Right. No, it should have one. Grip location. Oh, you know what? It should have it. What? Now, okay, you know what? It says that it's a rigid body 3D, and it doesn't say that it has a script assigned to it. So something is definitely wrong here. And as you can see, there is no script assigned to this thing. Oh, something has happened. Let's drag one again. There's the script. Okay, and let's also increase the distance. Let's go 08. Hello. Hello again indeed. Okay, let's try this. Just gonna double check my space. We got 4 gigabytes of space left on the recording hard drive. Woo. Okay. Okay, that's another crash. But now it's a different error. Invalid set index rotation. Oh boy. Alright. We'll get it done. Also, DaVinci Resolve has crashed because I suppose streaming, recording, and rendering was too much of it to ask. There we go. I have no idea where the flip that went. Oh, god damn it. Come back. I'm not done with you. Excuse me. Taking a drink. Alright. Load it up. Cool. Now, it sort of worked. It went everywhere, but it sort of worked. Closest grabbable grip location. Wait, hold on. We did reposition the element. Those values are still there. Grip position, grip just rotation. Grip rotation. In theory, this should have worked. Freeze becomes true. Held item becomes recorded. Let me double check that again. I know it's not gonna magically start working. Okay, so this is just a regular physics item. God damn it. There we go. We have a way of dealing with this. Okay, so it's got to be somewhere. It wouldn't just disappear. Yep. Maybe it would. That is strange. Maybe we have to freeze it first. And then set the path. Closest grabbable. Get the path. Freeze it. Oh, global position. No. That's the grab remote has to be positioned local to the hand. So grab remote. Yeah, that's supposed to stay here in this local space. Okay. Nice. There we go. Oh, we dropped it. There we go. Okay. Oh, we dropped it again. Man. I gotta learn to grip this thing, eh? Nice. Okay. You know, now that we have it as a physical item, like a real, true physics object, I think we might even be able to make it do some funky wonky stuff. Like we might be able to make it like recoil, right? Do all that good jazz. Okay. Now, when we let go, we need to actually let go. So, we're going to tell the animation player to play the reset pose. Cool. I mean, I think everything else is pretty much going to be the same. Okay, it's not too bad. The rigid body delay is a little annoying. But you know what? Maybe that's just the sort of game this is. Oh. Okay. Yeah. Okay. Okay, we need the ability to turn around. Oh, okay. Sure, that's how I left it. Okay, we need the ability to turn around. This is something that's going to be done by the other controller. So, VR hand right. We are going to... Oh, right. We're going to check input vector changed. Okay. So what do we need to do? We need to rotate our character. To do that, we're going to talk. We need to know yeah, okay. We need to know what is the position of the joystick on the right hand. Okay. How do we go about doing that? I mean, I guess we're always writing the data here. Let's do this. So turn executed, because it has to be incremental. Okay, so we're going to do if turn executed is true, then if the value on the x-axis, so left and right joystick movement, is above 0.7, then rotation degrees on the y-axis is going to be incremented by 45 degrees. And then we do if value on the x is less than negative 0.7, then we'll do the opposite. Subtract by 45 degrees. And then turn executed is going to be set to true regardless. Now, else, if turn executed is not true, then if the absolute value, which is positive or negative, is less than 0.2, then we will consider that turn executed is reset. Rotation, excuse me, value.x is less than 0.2. There we go. Alrighty. So, well, that's a big fat nada. I can move. Interesting. Oh, name. Whoops. Name has to be primary. That's kind of important, otherwise it's just going to react to any joystick. But it didn't work either way, so... Oh, turn executed has to be false. There we go. Well, still doesn't work. Okay, let's see if this works at all. So print right joy, right controller, name, value. Print S, please and thank you. There we go. Right controller primary. So it says primary. And on the x-axis, 0.9 or negative 0.9. Yeah, that seems like the proper value. So it has to be primary. And then turn executed has to be false. Which it starts at false. Yes. Maybe this never gets executed. Although we are doing value x, which is this value right here. And clearly, it has no problem going past negative. Oh, no. This is correct. Negative 0.7. And then, in that case, rotation degrees of the whole player should have gone subtract. Oh, hold on. Yeah, that's correct. This should have worked. Let's put a breakpoint here. Let's see if that even trips. Yeah, oh, it did trip the breakpoint. What? Excuse me? Do we have like debugger issues? Nope. It did trip the breakpoint, which means it's about to run this. Now, is it about to run it? I doubt it. It did run it. What? Hold on a second. Am I tripping? I'm tripping. I swear to God, it worked. But only when the breakpoint that got executed. So maybe the rotation keeps screwing with it? It might just be. Oh, come on. Ugh. Stop closing my project. Annoying. Alright. Let us see here. I think it might be running this and then immediately running this. So let's do elif. Oh, well, it was running something. The controller name is primary. This got executed once. You know what? I think all of my troubles will be changed, will be fixed if I do this in the process function or physics process. So right axis or right joy axis vector 2, and we're simply going to say if the name is primary, right joy axis is value, and then take this, go to physics process, and then we'll just do this. Oh yes, and then we need to use this variable now. Okay. Oh, it did rotate once. Oh. Interesting. It's not consistent. Let me try printing this here. Right joy axis. Alright, come on. Alright, so right joy axis. There you can see that it's... Alright, the x-axis is at negative 0.99 right now. And now it's positive 0.9. Wait. Okay, I'm gonna maybe subtract this, add this, but that's not really the crux of the problem. Okay, if right joy axis on the x-axis is above 0.7, oh, you know what? It's because it's running it all the time, you idiot. It has to first bypass this and then be considered to have become true. There we go. Now we got it. And I reckon now we can actually move it back into that signal. Right. Okay, so we're probably just gonna do that. No sense in dirtying up this whole scene. There we go. And I will just use value. Okay, I think that should work. Let's give it a test. Nice. Mm-hmm. The throwing mechanic is a little off. Cool. So that works. What do we need to do now? Well, if we have time, do we have time? Might have a bit of time. I would like to make the handle or the hand have the ability to pull back the slide of the weapon. Now we had that ability in the previous rendition of the project, but it was jank. It was basically just implied that you grabbed something and you just had to trust it. Okay, how are we going to handle that? Well, the way we're going to handle that is by giving the hand a gesture, first of all. Let's go ahead and do that. Okay, so this has the body, but we need to give it the slide. Okay, and I think we should be able to parent it. I don't want inverse though. Without inverse. Oh boy. Okay. There we go. Nice. So place that here. Oh. Maybe not. Maybe not. Here we go. Nice. There we go. What do we need to do now? Well, now we need to make a gesture. To make a gesture. How are we going to do it? We need to get this gun off on the side. Okay. Let's duplicate this animation and call it Group K Slide. Or just slide. There we go. Let's protect it and okay, I think that could work. Sure, that should be good. Keep the weapon disabled. And then we're gonna export the hand, override, and perfect. So, how do we handle this? Well, we will handle this by assigning yet another grip detect, except this is slide detect point. You know, that maybe, just maybe, this whole point node based system is gonna work out just fine. Maybe. Okay, so we're gonna place it here. And I guess we need to have, let's do this. Let's do weapon key. And the weapon key is going to be K17. Okay, in the hand, instead of using grip pose, we're going to do grip underscore and then plus weapon key. That should do it. Okay, now, in the same way we have done this, with this being the exception, we're going to need to do the slide. There's only one particular curious thing, and it's the fact that the slide, the slide works in a bit of a different way. Instead of pairing instead of pairing the weapon to the hand, we need to pair the hand to the slide. It might sound weird, but that's what we gotta do. Not the real controller, of course. The controller is still free roaming, but the hand needs to, the rigid hand needs to actually be attached to the slide. Okay. So, how are we going to do that? Well, this whole thing would have to be different then. As a matter of fact, we might actually have to use a totally separate condition which will override everything here if we touch the slide. That might actually have to be the way we handle it, and hopefully it works. But before we can even do that, maybe we should make the slide detect point be the remote transform node. 2 in 1. 2 birds with 1 stone. Okay. Because then we can check the distance to it. And also use it to pin the hand to the slide. Okay. So let's go to the, what should we start with? Posing or making the, let's do the indicator. And let's actually make the grab indicator be a single node. Okay? Alright, so we're going to say green for regular grabbable, red for weapon, orange for slide. Okay? So, to do that, we go up here. Okay, it is called grab indicator. And then, if we're close to the grip point, then can we do color? Yes. And it's just light color. Okay. So this is color red. Here, light color is going to be color green. And then we need a third one. So we're going to do this if it's a part of the weapon group, and if the distance to the slide detect point is less than this distance, then, well, orange, I think just orange is fine. It's got to be distinct enough. Okay. There we go. Let's just see if the detection works. Let's walk up to it. Well, it would be smart if we actually enable the light. Go green, yellow, no red though. And yet we grabbed it. Oh, I know why. This has to be elif so that the three conditions are connected together. Interesting. Man, that distance is really, really something. Okay, and then, well, we have a problem with this one is the fact that the detection is on the other side. Okay. Why is the detection on the other side? Didn't we... Huh. I guess we only flipped this one. We never flipped the hand area. So when hand axis gets flipped, like this, everything in here stays the same. Which kind of makes me think that maybe, for the sake of making it easier for us, we're going to put it into the hand axis. So that if we do flip it, the area node collision shape gets flipped. I don't know if that's going to affect our math. Grab indicator and the grab label should probably be inside as well, although that's probably going to mess a whole lot of stuff up. Okay. Let's see what's broken. Oh, okay. That's broken. Keep going. Oh. Ah, yeah. We can't really keep running the game in VR once it hit a breakpoint. Oh well. Okay, that's another crash. Global position of null instance. keep going. Okay. More crashes. Glow position null instance. That is here. Okay, there we go. And let's play with visible collision shapes so we can see what's happening. Okay, that's what's happening. But that shouldn't be a problem though. Well, it is a problem. Can we get the inverse of a transform? Let's say if it's the left hand. Maybe. Let's see. So collision shape 3D dot transform equals. So we talk to the transform. There we go. And can we get an inverse? Transform 2D. Hey, there is an inverse. Don't know if that's going to work. Transform.inverse. And then same thing here. Might actually flip it on the other side of the hand. Oh, and it technically did. But it did try, at least. Huh. Interesting. Okay, now there's a particular rule against scaling collision shapes. Interesting. This was inverse on both axes. Affine inverse? I'm just pointing in a poking in the dark in this case. Nope, not really. Okay, this is the position. Cool. If we flip this, that's what it becomes. But we have to flip the whole thing, which is like this. Okay. So what if we take this, duplicate it, move it here, and then we just destroy the one that we don't need. That's not the cleanest solution. Or I could just record these values right now and just use them. That's basically the same thing. That could work. Let's see. So if it's the shape left, it's this one and this one. Then position is going to be this position. Man, we can't copy the value this way. Still. Alright. I don't know why I'm copying the zeros. But okay. And then rotation. Rotation is actually nothing. Okay. This one, however, that's position. And then rotation degrees. 2900. Okay, and then we get rid of these. Hey, look at that. Oh. Whoops. Let's not leave this inverted. Okay. Ooh. That's that. And then that's that. Look at that. Oh, don't look at that. We need to work with our grip. Okay. Hand alignment seems pretty good. Yeah. Okay. Now, you can see how the guns, they have their own collisions, but the hands are still using their own. So I think what we can do here is this. Why don't we take the hands and we disable the tips of the hands, the fingers? Okay. So when we grab something, the fingers get disabled. Let's make sure that we don't have to. Actually, no, we do gotta keep it on for a sec. Let's see here. So this is collision shape fingers, and then collision shape palm. Okay, so the palm is the one that gets inverted here. Fingers are the ones that get inverted and rotated here. Now, when we grab something, held item, the collision shaped fingers have to be disabled. And then when we release, we re-enable them. Okay, there we go. No more fingers. Oh, come on. There we go. I need to work on my group sensitivity. Okay, so now you can see something. What can you see? There's still fingers here, which makes sense. It looks like the gun still has its collisions. But when I do this, it just phases right through. So what we need to do is we need to make the gun have take its collision shapes, and then migrate them to the hand. Not migrate, but maybe copy. You know? Okay, but that's besides the point. You can do this, even though that's not supposed to happen. All right, we haven't actually programmed the orange. We haven't programmed the slide detection. We only indicate it. So we're going to copy this condition here. It is a little far, though. It is a little far. I think what I might have to do is use another node, preferably at the tip of the fingers, maybe even this one, collision-shaped fingers, and then instead of using the proximity of the hand grip, I have to use the proximity to the slide, from the tip of the fingers to the slide. I think that might be better. And we have to make this check first, because we're also going to be making this check first down below. Okay. So we'll copy this and then go here, check if the hand is closest, if the tips of the fingers are closest to the slide. So if this whole thing, then else, if it wasn't that, then we can check the palm to be close to the grip, or simply execute our generic grab. So now here, what do we got to do here? Well, here we need to make the hand essentially get snapped to the weapon. Okay. We know that it's a slide detect point. Let's get VR. I think I could just get... can I get the VR hand? No, we don't need the whole VR hand. We need just a robot hand. Okay. Can I see the environment, please? Thank you. There we go. We'll take the slide detect point, and we're going to talk to the robot hand, or tell it to control the robot hand, and we will view the slide animation. And now we got to take the slide detect node and then position it in a way where the hand looks like it's grabbing the slide, like this. Of course, inversion is going to be a pain in the butt to try to set up. This thumb seems not optimal, this thumb position. I think that's all that I can do. Okay. So, that's what it is. Slide detect point. Now, it has to move with the slide. So I think it actually needs to be a child of the... It has to be a child of the weapon slide. But there's no weapon slide here, which means I may have to make a node 3D and then call it slide axis, and then place this point into the slide axis, so that besides this point there's also going to be this. Or we can put the slide, make the slide detect point B the parent of the slide axis. So it's just out here by itself, and then into it we place the mesh. I don't know if that's really over engineered though. Okay, let's try this. So robot hand. Go through this. This also doesn't address having left and right hand. Okay. Cool. Well, I suppose all we have to do is take the slide and put it into the slide axis. So when the slide axis moves, it moves the whole thing. So we get rid of the robot hand. Okay, that's fine. And then copy node path. We're going to have to go to the VR hand in the code. And then here, closest grabbable dot get node. We're going to get this node. And then remote path is going to be set to the hand axis. Get path. Okay, now let me double check something. Oh, that might be a problem. Hand axis is over here. We might have to talk to the robot hand directly. Alrighty. Well, let's see. Turn back on now. Okay, so we grab the weapon and we crash immediately. Invalidate Index global position on base null instance. Global position, I imagine this is what we got. Oh, slide detect point is not located in the same place anymore. It is in slide axis. Okay. Oh, come on. There we go. Oh. Well, that's a bit of an issue. It makes sense because flipped, flipped position, means flipped, geez. Okay. We flipped the hand, which means the remote transform node inside is also flipped, which that might actually be a problem. So it's quickly starting to look like we can't actually just nest everything inside here. Seems like grab remote is gonna have to stay where? Yeah, we're gonna probably have to take it out. Same thing with the label, same thing with the light indicator. You know, it seems like my biggest trouble, my biggest hurdle is desperately trying to make a system that just automatically flips everything. But it feels like if I just take the time to make the custom switch, it will just be okay. Or I have VR hand and VR hand right, and instead of that might actually work. Hold on a second. What if I do this? Make a new inherited scene. This is VR hand. Let's call it VR hand right. Save it. Make a new inherited scene. It's still called VR hand as a scene here. VR hand right. And then we're going to make a new inherited, whoops, not instanced, although that might be the same. Inherited scene. VR hand. Why does it still say VR hand? Oh, that's a GLB file. Okay. Objects. VR hand right. Okay. And then now we'll make an inherited scene from VR hand right. This is going to be called VR hand left. We're going to save it. And VR hand left is actually simply an inherited object from VR hand right. So that means that we don't need to worry about this or any of this stuff really, because we're literally just going to set it up to be flipped right here, right now. So hand axis, I might want to make this be at the top here. Okay, so hand axis, we flip this. This is just the mesh. Okay. Yes, just the mesh. Then this allows us to just simply position the fingers. There we go. And debug, grab indicator, all of that stuff is just going to be moved over here. And grab remote. I think this should now at least fix the inverted gripping, although we're going to have a bunch of code errors right now because of orientations. Oh, where are my hands? Oh, we crashed. It's weird because when it crashes, I can still look around in the game in VR. Invalid set text. Yeah, well, I know, because it's not in the hand axis anymore. A lot of this stuff is not in the hand axis anymore. This is still here, I believe, because it's part of the animation. Yes. All right. Okay, it's not the most intuitive way, or maybe it's more intuitive because it's just hands-on. That is right. Damn it. Close the engine again. Okay. Right. So this VR hand left, that is on the left. It's not supposed to be Oh. What? Excuse me? Okay. So this is 111. It's going down the z-axis. Okay, now if we go here... That seems to be correct. I'm not sure why it's 111 on all axes. Yeah, no, this makes no sense. Oh, hold on. I think it was this node that we rotated. Yeah, okay. And there should be no more code. Oh, you know what? I know why. It's because we still have the old hand in here. So the left one now has to be quite literally instanced this way. Alright. Cool. The controller ID is still old. That's not good. Also, we placed it in less than opportune place. Place it here. So this is right hand, this is left. There we go. And our rotation is not going to work now because the signals are gone. Oh, well. Well now. That's just not right. Both of them are using the same controller. Right hand, except it's not. This is left hand. Cool. And then while I'm here, I might as well establish the input vector into the player. Yes, that's left. Oh. To be expected, global position of null instance. What do we have here? Rigid hand, grab area. Rigid hand, but the grab area seems to not be inside, and I don't think it should be inside. But the left hand, same concept. Grab area is right here, which we can just, now that it's separate, we can just offset it if it, yeah, if it needs a little bit of offsetting. Cool. So, all right. Global position on null instance. Right. Rigid hand, hand access, grab area is not talking to that node anymore. All right. I'm starting to get lost in all the things that need to be flipped. That is okay. The errors will tell us. Okay. Position on base null instance with value of type vector 3. Invalid set index position on null instance. Here, grab remote. It is not in the grab area. Except I think that it might have to be because of the coordinates. Yes, I think it might have to be because of the coordinates. Hey, there we go. Okay, now that works with this one. And this one, not so much. Oh, okay. So it works, but it's off. And I reckon it is off because we have the left and the right hands, but we're not gonna have an absolutely abhorrent number of weapons. So creating a separate grip for the left hand, grip for the right hand poses might not be so bad, but this works. What's curious is that it was working before when I had both hands grabbing a gun, and then suddenly it stopped working. So that's curious. Okay, now what about this? We have the slide in here somewhere. Okay, we'll have to increase the sensitivity. Oh yeah, you know what? Our fingers are just in the way. There we go, and we crashed. Can I get method get path on null value? There we go. So that part is correct. We also need to make it show the grip animation. So while we're here, let's do that. So it's supposed to be slide. Okay. Slide underscore, and then weapon key. Yes. That should be okay. Okay. Ah, look at that. Look at that. So now technically we would need to get it to pull it back and then forward, and that should do it, right? And when we let go, we should we make it, well, by hand, right? When we let go, we need to make the hand return. God damn it! Return back to where it was before, and we also need a secondary pose. So that's a thing. That's fine though. Routine stuff. That is okay. Okay, so two things. Secondary pose for the left hand, and return hand back to where it was before when we let go of the slide. Okay. So we go here, grab the pistol, place it as a child temporarily, grab remote. Would be nice if there was a pick whip here, so we could just pick this item. Okay, there we go. Let's see, hand axis, animation player, grip, which means here, grab remote, has to be more like this. And I think that's basically all there is that we have to do. Yeah, it's just a position on left and right axis. So, we do need to know if this is left hand or right hand. Okay. Now we store the grip locations here. Grip location and grip rotation. We may have to make this a dictionary. So we do equals dictionary, and then right hand, and then left hand. Okay. And then same thing here. Actually, this doesn't have to be a dictionary. We just do a vector 3 value here. Okay. Good. Switch here. And now, here we go. Right, left. And then it does give us new value keys. I don't want that. Can we do a const? Can we do that? No. Export cannot be applied to a constant. Boo. Boo on you, sir. Okay, fair enough. So, first of all, the hands have to be able to discern if they're left or right. So let's make a variable side right. And then here, we're going to make it an export variable so that in the left one, we can go over here and say left. Beautiful. Export variables. Very handy. So now we're going to have to kind of redo the positioning, which is okay. We are working out a system. All right. So what is the location of this grab remote? Copy value. At least we can copy the values here. So this is for which hand? Left hand. So copy value. Go here. Paste value. Damn it. It only takes this. Aw, man. Son of a bitch. I can't actually paste the property like this. It will paste the whole dictionary. Oh, okay. You know what? Fine. We're gonna do this. Grip location L for left. We're gonna bring it back. It is gonna be a variable. And then grip rotation L. Same concept. Okay, and then grip rotation R. And then R. Except we're probably going to have to use the whole word. Left. Right. Right. Okay. So not all is lost. We can still make this. Because we have a function called get, where we can supply as a string the name of the property we'd like to get. And because we can supply it as a string, we can build a compound property name out of a string and a variable. Okay, so we go here, paste. That's left. Okay. The other hand left. So let's get rid of this or cut it out, if we will. Go to the right, paste it in. Okay. Grip. Oh, that's perfect. Look at that. Grip remote. Yeah, there we go. Okay, so take the grip remote, copy value. So this is this one. This is on the right. Paste value. Copy value into the pistol. Paste value. Okay, so that's good. Get rid of this gun. And now we go back to the code. And when we need to grip something, we're not going to talk to the variable. We're actually going to get a variable called grip location underscore, and then we're going to use the side variable of the hand to finish the name of that property. grip location underscore plus side. And that should do it. Grip underscore location underscore left. Grip underscore location underscore left or right. Perfect. Alrighty. Thank you, Godot, for offering the features that can be this flexible. Turn the controllers on. Come on. There we go. Okay, that's just a physics body. Nice. And oh, physics body, come on. Nice. There we go. Okay. So that's good. And then let go. Cool. We'll fix that after. Okay, so the only thing we need to do now is to make the hand return to where it was after we release. Now we have the hand axis and we have the robot hand. We need to record the location and rotation of the robot hand. So let's do var hand initial transform. I think we can run this on ready. And what we're going to do is take the robot hand and then get its transform. I think that's it. So now, when we let go of the hand, of the slide, we need to reapply it back, but first we have to know if we are even holding a slide in the first place. We might be able to still record. Nah, we're probably gonna have a variable. Holding slide. False. Okay, so when we go here, holding slide becomes true. Okay. And then we still need to do held item to be closest grabbable, because we're going to need to talk to that held item and talk to the slide, this remote path. Okay, so copy this, go down here. If the held item is not null, first things first, if holding a slide is true, then held item, yes, held item is what we talk to the remote path and set it to node path, an empty node path. Next, we don't need to play an animation. We are going to have an else statement here. We don't need this. All of this has to happen only if we're not holding a slide. So that means we must have been holding the gun. Held item becomes null. Fingers become enabled, which really only needs to happen when we were holding the gun. And then we play the reset animation. I think that should be it. Oh. No, that's not it. We still need to do this, which is tell the hand to have its transform, which is location rotation scale, to go back to its initial one when it was recorded. And we're dealing with local transform 2, which is just relative to the parent node. There we go. Okay, and then orange. Nice. There we go. And then let go. Perfect. Okay. So when we pull it back, that's when it's going to need to pull the slide backwards. Okay. Cool. Now the question is how we're going to pull that off. Well, we still have our virtual hand here. So we should still be able to like get its relative location, right? And then let go, do that. We'll play around with tolerances for locations and tolerances of the slide. Or maybe even give ourselves the ability to detect the slide entirely. But we'll see. Okay, do that. And then pull back. So how do we know if we're pulling back? Well, I believe in one of my previous renditions of this project, what I was doing is as soon as I grab the slide, I would position a little invisible node at the location of my hand. And then as I'm pulling it back, I think I would just read the difference between the old location and the new location. Which may be kind of deceptive, because if I pull it this way, the distance still technically changes. Okay. Also, kind of curious that the remote transform is still, the thumb's on the wrong side. Gonna have to figure that one out. Okay. But that's besides the point. When we pull the hand... Actually, no, that's not besides the point. Why don't we deal with that now, since that's related to what it is that we were trying to do before. Okay, so if we do this... Hold on. Oh, bye-bye. Okay, if that's what we do, can we or can we not place... where is it? Oh, it's in the pistol. Right, we would need to place the remote transform node. But you see, herein lies the problem. Now this means that every weapon's gotta have two transform nodes. One for the left hand, one for the right hand. Slide detect point. Oh, and this slide detect point is like way out here, so we can't use its location. Huh. Yeah, that's why we couldn't detect the slide so well. Because it's all the way over here. The slide point. Man. Okay. Baby steps. So technically I would say that this takes precedence. Now we have two hands, and because we have two hands, we have the ability to detect two different points. To have two different points, but this is a pistol. This is a weapon. Are we gonna end up having two slides? Okay. Why don't we do this? First of all, let's add node 3D. Okay. This is going to be renamed. Actually, we need to do this in the weapon template. So first of all, node 3D. So this is going to be called slide detect point. We're going to keep it there. This is slide grip remote. Okay. So going back to the pistol, slide detect point, we have to restore that. Oh man. This is like way out. Okay. I'm gonna place this here. Fix. This has to stay out. Oh man. Fine. We'll just have to redo the grip. Inherited nodes can't move the hierarchy. Okay, bring that in. Keep that way. And then just double check if anything else is rotated. No, not by the looks of it. Put the slide back in. Slide axis. I don't think the slide has to be there. If anything, we could use the slide axis as the slide detect point. I think that might be doable. Less nodes. Get rid of this. Okay. So, slide detect point. Yeah, the position of the grip is gone, unfortunately. Place this right here. Okay, then put the slide back in. All right. Let's fix this up now. We need to fix up the hand. We might as well just spend the time here fixing or setting up the proper orientations, and then worry about the other stuff. So take the remote, robot hand. We need to tell the robot hand to play. There we go. Slide grip. And then we need to adjust this. And that's looking pretty decent. Now, that's for the slide grip remote right. So I think we are literally going to have to not worry about it too much. Just do slide grip remote right, slide grip remote left. Okay. So that's right. And then we're gonna... Oh yeah, of course that's been destroyed. Actually, I just do... No, I can't do that. Dang it. Okay, that's fine. Limitations. That's just what I have to work with. So this is right. Is this right? Yeah, because the thumb's on the left. Okay, here we go. Okay, that's fine. And then we clear the node. Go to the left. We're gonna have to do something about this hand though, because it is flipped. It is flipped. Let's see. Hold on. So this may or may not work. Let's see. So robot hand, but we will take the scale on the x-axis, and then maybe even in the weapon template we'll do that, and then set the x to -1. So here, okay, x-axis is up and down because our hand is animated sideways. So we have to do -y. Okay. Oh, come on. Why? Why? It just flipped everything. Mm-hmm. Okay. There we go. So that should do it. If I clear this, and then tell it that lines up, and if I clear this, and then go for this one, it lines up. Beautiful. So now we do this. And in the hand, see, we never actually went this far with the other project. We always stuck to like a template, always a template. Well, now we'll learn it. Learn it and do it. So we go to the hand, doesn't matter which one, the script is the same. And when we do this, slide detect point. Okay. So first of all, the distance has to be checked against what? Slide detection point. Which is no longer in the slide axis. It is just by itself. Now, if that's the case, we're going to go to the slide detect point, and then inside, we're going to be talking to slide grip remote, right or left. The right or left is determined by the side of the hand. Okay. Now, we go down here. We got to repeat the same thing here, except it's held item now. That should do it. And then finally, the angle of detection right here needs to be fixed. All right. Let's see here. Okay, that's 1. That's 2. Now we'll drop this. Oh, okay. Well, that slide detection is a lot more robust. Yep, that looks correct. And then if we do this, and then this, yes, beautiful. Oh man, cool. Okay, but now I can't drop the weapon, so that's lovely. What happened here? Why can't I drop the weapon? Oh, we got errors. Instance null. Set transform. Oh. Interesting. The robot hand stopped working. Fascinating. Okay, well, you know what? That's fine. That is okay. We'll figure that out afterwards. What I think we should do now is at least get the slide working. Get the slide working, get the slide moving. Okay. Okay, we let go. Do this, let go. Do that, let go. Do this. Let go. Interesting. So the problem is what, with the left hand? Yes, it is with the left hand. Ah. So it's something to do with the let go code. Interesting. Interesting. Hmm. Okay, that's fascinating. Instance set transform parameter instance is null. That is wild. Oh, you know what? Maybe it's because this is wrong. Slide detect point is, and then slide grip remote underscore and then plus side. That part is correct. It's not an issue with this. It's an issue, I think, with this. Okay, well, you know what? That's fine. We'll worry about it later. The problem now is that we need to be able to move the hand back. Now, we still have access to the VR hand. We still have access to the VR hand. So, what we need to do is we need to record where the VR hand is located, and then when the player moves their hand back, we need to record how far back they moved. But we also need to discard if they move it forward. And I think the way we can do that is by having a special node inside of the gun, an invisible node, which has a child node inside of it. And when we grab the slide, that invisible node gets positioned at the position of our controller, and the little child node will be always mimicking the position of the controller. So the parent node only mimics the position once when we grab, and the child node mimics the position all the time. So it's kind of like this. So node 3D. So this is slide pull grip origin, and then inside of it we're gonna do slide pull delta position. Okay, so when we grab the gun, this will be positioned at the controller only once, and this node will constantly try to get the set its position to the controller. And when that happens, this node will be moving in relation to this node. So when I pull the hand back, right, like this, we can simply read its local position, the z-axis, and then that's it. That's what we're going to be using as an offset. Okay. Now, I think that will work, but I cannot do this today because I think Dimitar needs to fix up the orientation of the gun, because right now the gun is facing that way, and that's not correct. It has to be facing that way because that's the forward direction. So I'm gonna wrap it up for today, and we'll just continue this next time. I would say pretty gosh darn good progress, and the quality of the interaction seems to be a little bit better than it was before. And I think the fact that we're actually taking the time to create the gestures and line them up, I think that's going to look a lot better as well. But that's going to be it for this time. Thanks everybody for watching, and we'll continue in the next one.